Processes are jobs to be executed on a computer, especially on a central processing unit or CPU. One of the states a process can be in is this ready state, and during the ready state, the processes are ready to resume or begin processing a particular job. When a process is in this ready state, this implies that the process is in the state just before the running state. This also means that the process has the CPU availability, and the CPU is available to accommodate the process, and it also has all the resources it needs to be executed on the CPU, including the memory space. Another important process state is this waiting state. During the waiting state, the process is waiting for a certain resource or resources to become available. Some of these resources include things such as CPU, memory, and especially peripheral devices, such as a CD-ROM drive or a printer, etc. So one of the examples could include a printing job, which can be only done when the printer is available. So you send out this access request to the printer, and you have to be waiting until you get a green light from the printer. Another name for this waiting state is blocked, because the process is essentially blocked until you have access to the resources you need to run the process. The supervisory state is when a process requires privileges beyond what's expected, especially for security reasons. So we have situations such as when the process is involved in changing the system configurations, also involved in installing device drivers, or finally doing anything related to security settings such as changing passwords and so on. So in these cases, the process goes into the supervisory mode. Finally, when the process is done executing on a CPU, it goes into the stopped state. So the process could be finished naturally and gracefully, but at the same time, the process could be terminated abnormally because of an error, and so on. When the process goes into the stopped state, it releases all the resources that were assigned to itself, including the memory space, and as well as all the other resources. Since we covered all the states a process can be in, now it's time for us to put everything together. So the process could be in the ready state, running state, waiting state, and stopped state. One of the reasons why we have so many of these states for the processes is the fact that we are using this concept called time slice in our operating systems. And the time slice concept came along because we wanted to implement the idea of multitasking. A lot of times you open up many windows at the same time, meaning many processes associated with those windows. And typically, you have only one CPU to run these processes. And of course, these days we have multi-core CPUs and so on. So it is possible for us to be able to running multiple processes at the same time. However, in the past, when the operating system was first created, we only could divide the CPU time up into these time slices so that the processes could take turns in terms of getting executed. So this whole idea of time slice made it possible for us to do the multitasking, running multiple processes at the same time on a single operating system. And when it comes to which process gets to run on the CPU, this particular element on your operating system called scheduler gets to decide that. And the scheduler is also referred to as program executive because of its role in terms of deciding which process gets to use the CPU time or time slice. So to summarize, when a new process is created, it goes into this ready state, and if there is nothing running on the CPU at the moment, it can move on to the running state. And depending on what happens to the process, let's say the process can only do a portion of what it was supposed to be doing, it will go back to its ready state and wait for the next time slice. So if there's no competition, it will of course go back to the running state. But if there is another process that needs to be running, it will have to wait until all these other processes to stop running or finish their work. Once that particular process finishes all it's supposed to be doing, then it can go to the stopped state. However, a lot of times what can also happen is while the process is in a running state, it may have a need for a particular resource. It may have a need for a particular resource, such as a printer. So in that case, you have to put the process in this waiting state until that resource becomes available so that other processes in the queue can be still running on the CPU. And once the waiting is over, the process can also go back to the running state, and then when it's done, it will eventually go to the stopped state, or if it's not finishing up all it needs to be doing, it will go back to the ready state and then come back to the running state.